Well, I'm debating if I give it in Spanish or English, but since I'm trying to get money from Tom Ford, I might like to him to understand. Yeah. So anyway, I'll give it in Spanish then. Uh, I'm sort of, yo estoy como aquí medio colado, ¿verdad? Porque this is not a company. But I had the opportunity by Jesus to give a presentation, and I'm the, let's see, this is the, I'm the director of the NASA University Research Center. It's a center for advanced nanoscale materials. This is funded by NASA since 2003. So we are in our second cycle, which ends in 2 years. And this is a group of very fine scientists from different campuses. And these are from Rio Piedras is Fuad Aliyev, is a physicist. Luis Fonseca is a physicist. Kai Grivenov is a biochemist. Yasuyuki Ichikawa, a theoretical chemist. Ram Katyar, physicist, and Rita Mayor, chemist. Gerardo Morel, physics. Raptis, which is around here, is a chemist, and Brad Wiener, which is a chemist. We in the second cycle of our center, we added groups from Mayagüez and Calle. We have two very fine scientists from Mayagüez too, Arturo Hernandez and Maria Martinez, and Wilfredo Taño from Calle. This is our grand number, and this is my email address if you have any information. This is 10 minutes, so it's very short, I know, and I'll just go by some of these slides. And this is a very interdisciplinary research group in the area of nanotechnology, and we work in 4 areas. One is in life support systems, advanced high-energy materials, nanocarbon-based sensors, and carbon-based sensors and biosensors. And we have been working in this area for several years. And as you will see, I'm just going to give you a splash of each of these IRGs so you can see which is the interest of companies to help us develop this technology. If in the area of life support system, we are trying to purify air and water. And in the area of high energies, in the area mainly of lithium batteries, and you know that area is a very hot topic today. And we have very fine scientists in Rio Piedras that are in the threshold of energy for lithium batteries. And in the area of carbons and biosensors, these two types of sensors, we are developing very sophisticated sensors using nanotechnology. And the reason I'm here is because NASA has this it's called technology readiness level. And technology readiness level is sort of when, you know, if you are in the basic science, you're in TRL1, and as you go further and further up, you go through all this process. It's sort of what Tom Ford showed this initially. And at the end, it's sort of TRL9 is when you have something in the space station or a satellite or something like that. Our group, I'll show you, we are in the TRL3. We are in the technology development now in some of this IRG, and that's why we need the help of the trust and investors in trying to develop this technology. This is sort of our areas of things that we want to do, commercialize our technology, not only for NASA, enable technologies and test beds for different applications in that as I showed, and also obviously STTRs and SBIRs is sort of our goals. So our applications right now is trying to develop the next generation of batteries and fuel cell using nanotechnology and sensors and different areas. And these are sort of the areas where NASA is interested. But things that you do in NASA are also good for Earth. So one of the areas is in the area of purification of air and water. And one of the lead scientists here is Arturo Hernandez, which has a couple of patents, actually, and has been developing porous materials to remove CO2 from air. And these are sort of his motivations, and these are part of his applications. Basically, it's the removal of CO2. And currently, he has one of the nanomaterials that is much better than what NASA is using right now. So NASA is very interested in this nanomaterial for the purification of air. And this is the device that NASA uses, and his materials will be used in the next years in this type of system for the purification of air. So this is an area that has a lot of promise in terms of technology. and we are very proud of his work. The other area is sort of the purification of urine. This is sort of a urea electrochemical bioreactor. But the reason is that trying to send water to space is very expensive, so they have to look at ways of recycling water or urine or waste in the space station. And one of the areas of purification is using osmosis and filtration and vapor compression distillation, which is actually systems that we use in Earth for purification of water right now. And this is basically the area that we're working is trying to help in the purification of urine, in trying to remove one of its main components, that is urea. And these are sort of the targets for drinking water in terms of ppm and other applications. And still, the amount of urea that you have in the system is very, very high to make it drinkable. So we are, in our group, we are working in an area in this direction in trying to prepare a system. And this is sort of, there's a patent application on this, and trying to develop a bioreactor to help on the removal of urea. So this is the forward osmosis and reverse osmosis. This is the osmosis process of water purification. But here you have the what we call the bioreactor, which is basically having urea with an enzymatic reaction transformed to ammonia, and ammonia is pre-concentrated here, and then it's pulled to a fuel cell system that can generate electricity. So it will be sort of purifying water while producing electricity. This is sort of the system that we're building, and this is basically, it's going to be in Facundo West or Rio Piedras in a couple of months. The other areas is in the area of high energy materials, and here the lead is Dr. Ram Katiyar. If you know, Ram Katiyar is one of our lead scientists of UPR, and he's working on lithium batteries. Lithium batteries is one of the areas of, in addition to solar energy, obviously. Lithium battery is for, try to store energy, and one of the areas that he's working is developing nanomaterials that can have a higher, what it would call higher volumetric energy density or higher specific energy density. So this is comparing to different batteries in the market, and lithium batteries here. So it's much smaller and lighter. Well, to tell you the truth, Ram Katiyar from our group has one of the best cathode material for lithium batteries right now. And we are preparing in NASA, we are preparing what is called a pouch cell to scale up, prepare a test bed for this material. So if somebody is doing research in lithium batteries or in that area of nanomaterials, Ram Katiyar is one that you should talk to. And Gerardo Morel is also working in this area, but he's working more in the anode material. So it's an area that we are trying to also promote and try to develop. The other area is in the area of carbon-based sensors, and these are three areas that we have been working very strongly in our group. Katiyar, Gerardo Morel, Brad Wiener, Fonseca, Otaño, and Martinez. Martinez from Mayagüez, Maria Martinez. And it's just different areas of sensing: UV radiation in the hard UV, temperature sensors, and gas sensors. And I'll just show you one that is prepared by Wilfredo Otaño. It's palladium nanostructures. And here he's trying to develop what he does is he prepares these very, very nice nanoshells. He's using polymers. He has this technique that he has been using to develop areas with polymers all spread where he deposits the palladium, and the palladium turns to be like a nanoshell in the nanometer region. And he has been already doing some sensing of hydrogen with a small device, which is scalable again. And the good thing of his system is that it can detect hydrogen very fast, and it can restore again to its level and detect continuously. So it's very reproducible, the detection of hydrogen, and it's one of the leading technologies in in our system too. And the last one, which is the area of biosensors, which is in the lower tier level, but it's trying to develop sensors. And here is an example of detecting lactic acid with lactate oxidase. This work done by our colleague Kai Grimenov. And the idea here, or what we are doing, is we are working now with an array of sensors to develop a device for not only sensing lactic acid, but also cholesterol and other chemicals that are important. And this is using technology from NASA and technology from our lab. This is, so these are sort of the areas that we are working in, and we feel that in the next year or two, we will be able to spin off some companies, startup from our work, and we would like obviously the support of the Science and Technology Trust and some people, investors that would like to participate. And to finalize, I just want to let you know that we have one of the most sophisticated nanotechnology characterization facilities in Puerto Rico. We have one in Rio Piedras, and we're going to be building one in Mayagüez that's going to be finished soon. Actually, with funds from Fideicomiso if we are waiting for that, but we will. So we are hopeful that will be. But we have one of it's a very selected scientific instrumentation that if you're doing nanotechnology, you need to use this facility to do the characterization. And the group from the company, the previous company, has been using some of these facilities. So it's very impressive actually. So we have this one this started with NASA funds, and then it catch up with NSF funds. NSF invested over $2 million in instrumentation. And you can do a low resolution TEM to look at very not very high resolution, probably the nanoparticles that you saw before. But if you want to see atoms, how the atoms are structured, we have the 2200 FS. It has its separated space. It's controlled from outside. It's you can see atoms very nicely and well distributed. So this facility is available, and we're using it. This is Maxime Guinel, who is the director of the facility. We hired him 2 years ago, and he has been doing excellent in trying to develop this facility. So I think with this last slide, I'll finish. I just want to show you that nanotechnology is being done in UPR and Mayagüez and Calle, and that our center, one of our goals is that we would like it to transform into a company. And that's important because when you have funds from NSF or NASA, they're not going to go give you money for the rest of your life to do this type of technology. You will have to spin off and create this company. So we are ready for that, for some of these technologies. So thank you very much.